Good afternoon, everyone. Happy Monday, March 20th, 2023. In this video, we're going to be talking about an El Nino that's building across the eastern and central Pacific. So this video will be quite a bit different than my recent videos where we focus on the US, we talk about the weather, but this one is going to be different. And we got to talk about this one because this is going to impact our weather pattern for the summer and also for hurricane season, and then eventually turning our back towards winter time for 2023 and 2024. So starting off this, we're looking at our recent evaluation, current status, and predictions. This is updated by the Climate Prediction Center or National Centers of Environmental Prediction every Monday of the month. So if you think about it, next Monday they'll have a new update out, and then the following Monday another update. So 4 to 5 Mondays per month or so they'll have these updates. So here's the outline. We're going to look at the summary, the recent evaluation, and current conditions. We're going to look at the oceanic Nino index, looking at the sea surface temperatures in U.S. seasonal precipitation and temperature outlooks, and the overall summary after that. So, of course, this is the final La Nina advisory according to the National Centers of Environmental Prediction. That's what they have been saying. This is turning to a neutral pattern now. So La Nina conditions, you can say goodbye to the Christ girl because she is going to sleep, and the Christ boy is waking up from bed. In other words, a little analogy to put it into simple words. So we're looking at neutral conditions that are expected to continue through the northern hemisphere spring and early summer, but there are signs we might even get into an El Nino by mid to late summer at least, at the very most or at the very soonest. So recent evaluation of equatorial Pacific sea surface temperature departures. So negative sea surface temperature anomalies have gradually weakened across most of the equatorial Pacific Ocean since last December. Okay, so you can see the chart here, kind of a I can't even say it. It's a weird Greek term for these graphs that we look at, kind of a stretched out Mercator map of the past sea surface temperature. So you can see here, we've been in a La Nina for a while here, and we're already starting to see some of those warmer anomalous sea surface temperatures building in across the eastern and central Pacific. And this is April of last year. Here is last summer, here is fall, and here is winter. So the further down you go, you get to more of the present. This is the oldest image, this is the newest image. And so you can see how this all has progressed with these below average temperatures, and now we're starting to see a huge warm up taking place now in the eastern equatorial Pacific. So the Nino region sea surface temperature departures, recent evaluation here, or evolution, I should say. If I got that wrong, I'm sorry. So the 1+2 region is the warmest. We're at about 1.4 degrees Celsius, and you're probably telling me, oh, it's an El Nino already. Well, you got to have it in the Nino 3.4 region. So I'm going to box this in red so you guys can really see that clearly with what I mean here. So you want sea surface temperatures here to be at least 0.5 degrees Celsius above normal or warmer for a declaration of an El Nino. If it's 1 degree Celsius and greater, it's a moderate El Nino. And if it's 1.5 or greater, it's a strong El Nino. And if it's 2 Celsius above normal or greater, it's a very strong El Nino. So right now, we're technically in a neutral pattern phase at this time, with strong agreement that there's going to be a flip-flop here to an El Nino in a couple or in a few months or so, maybe a little longer than that. So even so, the 1+2 region here, which is this white box, they drew up an example here. This is not a lot of space in the ocean. You really want it here in the central and eastern Pacific for those waters to really warm up. And once they do, we can really start seeing the patterns change. The Walker circulation relaxes. Things turn more El Nino-like when you see that happen. So in the last 4 weeks, sea surface temperatures were below normal near the international dateline and above average in the eastern Pacific, which again we can see here clearly that warm up in the central and eastern Pacific. And then just kind of scrolling down through this PowerPoint, we're not going to look at that. This is more of a Mercator projection map. This is really hard to see though, but you can see areas in blue, the blue spikes, moving my face out of the way so you can see that, indicate a positive phase of the thermocline slope index, usually means La Nina. If it's orange, it goes into El Nino. Simple terms to put it into. All right. Now let's go further down. This is my favorite chart right here. Subsurface temperatures and anomalies were negative until June 22nd. So this is looking at the central and eastern Pacific upper ocean. So all the way down to 300 meters below the surface in depth of the ocean, weekly average temperature anomalies before becoming briefly positive. So we can see they kind of took note of this little positivity, and we were thinking that, oh, we might get into an El Nino, but the subsurface temperatures were not really favorable for that at the time. That's why we went straight back into the negative for a second dip into a strong La Nina pattern. And now recently we have had this huge warm up in November and December in the subsurface. And again now, look at this, really big warm up just recently. And you'll see why that's important in just a second. So negative anomalies weakened and returned to near zero. Since then, anomalies have been becoming positive and more increasingly rapidly in the recent month or so. So now when we look at the subsurface temperature departures in the equatorial Pacific, we can see why that's important. And I'll show you another animation here in a little bit in the video. So you can see above average sea surface temperatures or subsurface below the surface. This is not at the surface, okay? This is looking down through the water. Think about you're diving 150 meters down below the surface. You'll find that the waters there are warmer than normal than they should be, and that's what this illustrates. We have warmer than normal sea surface temperatures here in the subsurface. So you're probably asking, why is this important? Okay, I will let you know when we get into this animation right here. Okay, we'll kind of visit that in just a second. We're just going through the presentation PowerPoint here really quickly. OLR anomalies have been above average here, which indicate that the conditions there have been drier than normal. We want blue colors. That means it's wetter than normal. Okay, actually, I believe that's what that is. Oh no, these are actually trade wind anomalies, I believe. Yes. Oh no, wait, no, wrong thing. Man, there's too many things to look at here. So I was right. So above normal or above average OLR means more deeper, or wait, no, below average thunderstorm activity, and blue colors indicate above average. Hope I got that right. I haven't looked at these things in a while, so bear with me here. The interseasonal variability, the MJO, can significantly impact the surface and subsurface conditions across the Pacific Ocean. So, related to this activity, significant weakening of the low-level easterly winds usually indicates an eastward propagating oceanic Kelvin wave, which we already have seen, and we are starting to see another one of those propagating over to the central Pacific near the international dateline. Once that occurs, we might see a huge influx of warmer than normal sea surface temperature rises in the central and eastern Pacific within the next month or so. So here's another look at the trade wind anomalies. This is wind and not convection. So blue colors indicate stronger than normal trade winds in the right around the international dateline. They have since weakened and at times have reversed or slackened quite a bit. And that's the areas in orange here. And this literally illustrates that. Upper ocean velocity potential anomalies, areas in brown and yellow indicates subsidence in the atmosphere. So we got suppression, no thunderstorm convection going on. It's drier than normal in this area. And then areas in green and blue indicate enhanced thunderstorm activity or upward motion in the atmosphere, usually a breeding ground for tropical cyclones in the summertime. All right, we'll skip that. We'll go down to here. So our recent index here in 2023, that is December, January, February, the first blue window of the year has been filled in, and it's 0.7 degrees below zero, or literally in the weak La Nina territory. But we're going to start filling in these red boxes, I'm quite sure, in the next few months. You're going to notice these averages are going to go up and up and up, and when they get above 0.5, that's an El Nino. That's the warm ENSO phase of the Southern Oscillation Index too. So the probabilistic ENSO outlook calls for a 60% chance of El Nino conditions for September, October, November, and December, with very little chances of La Nina and lower than normal chances of neutral conditions returning. So we're going to probably favor El Nino here for late summer into the early fall months and into winter. We're going to skip this. This is very hard to understand and kind of wrap your head around. So we're just going to kind of go simply down to here, trying to make this as simple as I can at the same time to not bore the hell out of you guys. Oops, I just cussed. Sorry. I just cussed. I meant to say, so I do not bore the heck out of you all. Okay, I might have to edit that out. I'm sorry for saying that. So the CFS version 2 ensemble mean does indicate that sea surface temperatures will be warming up. They are already warming up, and they will continue to go up. We could be looking at a strong El Nino perhaps by late fall into early winter. That is September, October, and November. Right around that 1 to 1.5 degree line, right here, roughly. And some of the ensembles do indicate even 2 Celsius. So that would be a very strong El Nino if this actually comes to pass, right? It's very far out. It's like 9, 10, 11, 12 months out. So we just don't know exactly how this is going to pan out. We still got to get to that that predictability or interseasonal predictability barrier. Once we get past that, we will know a lot more information with what is going to happen. Of course, there's been anomalous ridging back across the east, with anomalous troughing across the western U.S., which has contributed to really cooler than normal sea surface temperature departures over the northwestern U.S., including for the west and the northern plains, with above average lately overall in the long term in the last 30 days. So it's been a really warm one back east. And yeah, you guys, you know, I don't blame you guys saying it's been warm here, because it has been quite the spring. It's been an early spring for a lot of you back there. So now, to my favorite part now, again, just kind of looking over our current sea surface temperatures actually in better detail. We can see here that, yes, El Nino is waking up. The Christ boy, he was snoring for a few years. Now he's waking up, and he's going to show his powerful colors here. And we're already starting to see 2 Celsius in some of these anomalous areas. We're even starting to see 3 Celsius and even 4 Celsius right along the Peru coastline of Central America. That is very, very substantial. So it is going to be interesting to see how this all over here will grow as it tries to move a little and slosh westward very slowly but surely, and how the westerly wind bursts will interact with this. Do we get a huge growth here of El Nino in the month of April? We just don't know exactly, but there is some telltale signs we're going to start seeing things really ramp up here as far as El Nino. Now, as always, El Nino is not, okay, it is not a weather system by any means, so please understand that. It impacts our weather pattern indirectly. So usually during El Nino years, the deep south, The western U.S., including for the desert Southwest, usually receive well above average rainfall and snowfall typically during El Nino winters, okay? During La Nina periods, it's drier than normal across the deep south, the Intermountain West, as well as the desert Southwest and the Southeast. So it's just kind of a flip-flop kind of pattern here, and I'll show you that here on the CFS. But what I do want to show you is the subsurface temperatures. Remember this right here? Let's kind of zoom up really quickly. Let's go up, up, right here. Remember this? Well, we're seeing an animation of that clearly on the Climate Prediction Center website. So these orange and red colors indicate above average subsurface sea surface temperatures, kind of down here deep down, all right? So we're looking through the ocean in a two-dimensional image, and we're looking down. So blue colors indicate cooler waters, right? And these are near average sea surface temperatures. Of course, you don't get a lot of warming down there because the sun doesn't penetrate the ocean 450 meters down. It's usually very dark. But when you get higher up, the ocean waters are brighter, and the sun is able to penetrate and warm up that water due to radiational or kind of microwave radiation return warming. So we can see with what has happened, this always pauses on me, and I don't know why it does that. So let's go back and click on it. So when these trade winds relax, okay, the westerly or the easterly winds blow from east to west on a normal basis, but when they relax or reverse, all of this warm water is able to slosh eastward below the surface, right? We can even see this taking place on our equatorial sea surface temperature. These are not departures, these are actual sea surface temperatures below the surface, the skin of the ocean. And we can see in recent frames how this warm water is beginning to slosh. It's kind of like, how can I explain this? A little analogy here. Think about a fish tank, okay? Imagining a fish tank, all right, on your table, and you cool that water down, okay? You make the water maybe about 39, maybe 40 degrees Fahrenheit, okay? Think about that. Just picture that in your head. Now pour a pot of boiling water into your fish tank at the very surface. On one side of that fish tank, you'll notice the warm water wants to slosh, kind of float on top of the cooler water below, and it wants to slosh in one direction, right? It wants to go to least resistance. That's what this is illustrating. So basically, the pot of boiling water, in this case, is moving towards the east. That's the thermocline index that you're seeing. So what we want to see here is these waters here to really warm up, to kind of match the ones in the western Pacific in the subsurface, roughly about 120 degrees east. So hopefully that explains that very well. Now, another thing I like to look at is the Southern Oscillation Index. This is basically the pressure difference, and I will show you an example here on the GFS what that all means versus kind of a La Nina or El Nino. And this kind of illustrates with what the pressure patterns are doing. What are the circulations doing, right? So in recent weeks, in recent years, we've had a strongly positive Southern Oscillation Index. Basically, that means the pressure is lower than average over Indonesia, over India, and Australia, especially in Darwin, Australia. You know your bearings, you know geography really well, you know where Darwin is, I'm sure. But occasionally, when you get an El Nino, the Southern Oscillation Index flips into a negative state. What that means is there's above normal pressure anomalies over Indonesia, Australia, and the Indian Ocean. It usually means very dry and drought-like conditions over Australia, usually over India and Indonesia, and it usually suppresses the typical Asian monsoon or Indian monsoon. So you'll hear about that this summer, that, hey, it's been really dry in India. You can blame El Nino for that because the pressures are higher than normal there than they typically would be. So we can see here the 30-day anomaly, or the 30-day contribution on average, has dropped. Look at this. I mean, in early March, we were at about 10 on the index. This is not pressure, okay? This is just a number, an index, like an index of what this means, in other words. So we can see in recent, like the last couple of days, it is now negative. Not super negative. It's not like, oh, we're in El Nino. Okay, it's negative. It needs to be negative, a -7 for at least 3 consecutive months for it to be declared as an El Nino for the Southern Oscillation Index. Right now, overall, it is still in the positive territory because we can see the 90-day average is at 10.57 as of today. But we also got to look up here too. This has been really positive over the last 90 days, as you can see here. In January, it's been positive, and it hasn't changed much, but it really went positive in December, which is why we got to this La Nina that extended itself a little longer. So now, another way to look at this and visualize this is on the GFS model. This is an actual forecast, but you should not use this, okay? Because this is going to be an example in the next 5 days, because this is this was released on March the 20th at 12Z on the GFS 2023. But this is just kind of illustrating you with what I mean by this, okay? Lower than normal pressures are being represented here in this forecast model on the GFS, right? That's a signature, an early warning sign that we have El Nino coming. It is a little bit near neutral over Indonesia and Australia. So this tells me here we're kind of getting the pressures in a way that would favor El Nino, slackening of the trade winds, and a lot of moisture and heat, latent heat release here in the form of upward motion. What does that do? That changes the jet stream, that changes the pattern around globally. So that's what we are headed into right now, with lower than normal pressures in the central and eastern Pacific. We'll see what happens over here over India, but typically it means above average sea level pressure. So another way to look at this is on the climate forecasting system map. I really like showing this because it illustrates to us what is coming. So when we look at April here, these are monthly sea surface temperature anomalies based on the 1984 to 2009 model climatology. So when we go forward in August, we can see how El Nino really ramps up. Look how strong this is. Okay, a strong El Nino potentially on the deck of cards. Now, just because we see this does not mean it's going to happen. All right, there may be another one of these trade wind bursts that mix up the water. It cools off the subsurface temperatures, or it cools the subsurface below, and it cools the skin. And what that means, well, it might mean no El Nino. So we're not quite sure yet if an El Nino is developing, but we are already starting to see things, a warning sign of that occurring. Pressure anomalies, really quickly. Man, this is a 22-minute video. You can clearly see just how important El Nino really is. Below average in the central and eastern Pacific, well above average over Africa, Indonesia, India, and Australia. Suppression of thunderstorm activity, tropical cyclones coming off of Africa, typically a suppressed West African monsoon season. And we could even see this on the CHI anomaly forecast. I mean, look at all of the sinking motion there and the rising motion in the central Pacific. So it might be a very busy Eastern Pacific Atlantic hurricane season, and a more of a suppressed one perhaps over the Atlantic area. That's a video for another day with my Atlantic hurricane season forecast, which I will be making my first one probably in the next month or so on that. Okay. Another way to look at this too is the jet stream pattern too. Really quickly, just to kind of add in something, let's go to here. We can see the jet stream is typically stronger with above average precipitation being represented in the areas that have the stronger jet stream. Another way to look at this is the monthly precipitation forecast, and look at that. Areas in green usually indicate wetter than normal conditions, and areas in yellow and brown indicate usually below average precipitation. Oh, poor Hawaii, going to be really dry. California, we don't need any more rain, but it looks like it could be a really wet winter of 2023 and 24. I'll keep you updated, though, when that gets closer. But also, you got to stay up to date on my YouTube channel by clicking the red subscribe button right now to get latest weather updates on an everyday basis. You cannot miss on any videos, all right? So if you haven't subscribed yet, please do so. It means a lot to me, and I'm sure it means a lot to you too, so you can get notifications every time I make a video. Leave a comment and share this video with your family and friends, and leave a like too on the video. Not only that, check out the Mesovort WX weather website. There will be a link in the description below this video, along with my Discord server. If you want to participate in that, all the links are in the description, and they are 100% free. There is no cost whatsoever, because being free is being free, right? So I hope you guys enjoyed the video, and I will catch you guys in the next one. Peace.